Now let's dig deep into the some of the SonarQube concepts. So we'll begin with quality. So what all stuff that a quality consists of, such as bug, code smell, cost, depth, issue, measure, metric, new code definition, quality profile, rule, remediation, cost snapshot. Everything we're gonna understand using this. So let me get it here. Yeah. So come to the projects. And here you should see. So let me come to the issues, and so here you should find out all some of the examples. Let me click on, let me zoom in. Yeah, so I'll scroll down one by one. Yes. So first one, there are, it begins with three types mainly. After that, it's severity. The first one is bug. You see that? You can see that on the screen. Bug. What does a bug mean? So it's widely used by software guy. A bug, a bug, a bug, a bugger. So bug is an issue. It's an issue. You see that? We are in issues tab, represents that issue, that represents something wrong in the code. If this has not broken it will, and probably at the worst possible moment, this needs to be fixed. This needs to be fixed. And I'll show you one example of the bug rule. So I'll go to the Java, and this is the bug, the first one. So what's the bug? So equals and open and close parenthesis should not be used to test the values of atomic classes. If you use this, that's called as a bug. And equal plus should not be used. Instead of, you have to use plus equal here. Okay, plus equal, not other way. So, and one more bug, let me scroll down, let me click on bugs only here. So let me scroll down. Yeah, Java, and let me filter this using bugs. Yeah, so one more bug for Java. Bug is filtered. So one more bug, at the rate of non-null value should not be set to null. That's correct. If you set it, you're going against the rules of Java itself. Then obviously it's a bug. But what will happen if you do that bug? If you keep that bug, so it if this has not broken it, if it will, and probably at the worst possible moment, this is gonna create an issue. So that's why it needs to be fixed. It needs to be fixed at any cost. So that's what the bug is. And the second one we have is code smell. You see that the code smell here? So I'll come to the issues, and here is the code smell. So what's code smell? Code smell, a maintainability related issue in the code. Leaving it as is means that at best maintainers will have a harder time than they should making changes to the code. At worst, they will be so confused by the state of the code that they will introduce additional errors as they make changes. That's the biggest and the worst aspect of code smell. So I'll show you. I will select the simplest one for, so that it will be easy for. I think most of you guys know, because you are data scientists. Most of you guys working on Python. So I'll show you the code smells of this. Okay. So some of the code smells. Pass, example pass. Pass should not be used needlessly. Okay. What happens if you use continuously? That you have to answer. Okay. And total 111 we have. And one more. So I'll just scroll through it. So double prefix operators, not and these two things, not and tilde. Not and tilde should not be used. If you use it, what will happen? And functions and methods should not be empty. You just simply randomly you write a function and keep it empty. No, those are very worst things. And even functions and lambda should not reference variables defined in enclosing loop. Functions returns should not be invariant. Even that also. You write a function and you give some arguments, or we call it as a parameter because we are defining the function. But inside the function, in the second line, you write a return statement. Inside that return statement, you should not leave it. You should not leave it empty. And there are more. So what happens is, if you have this uh, code smells, if you have this code smells inside your source code, so after that this may lead to some errors or some bugs. So when it leads to some errors, so the maintainer has to come and check, and he has to find out, and he has to solve that. So for them it will be a nightmare. In addition to that, this code smell is going to create new kind of errors. It's going to impact the other functionalities of the your application. So it's going to lead to new types of errors. So that's the reason you have to be very, very damn careful about this code smells. Okay, let me get into the issues. So in addition to that, we have a lot of other information. So scope, resolution, and status, security category, creation date, and language, and rule, tags, a project, other. Okay, let me scroll down. I'll give it here. So a few more things here. So these are different tags that were given. So few more things to be discussed in the quality. The next thing is cost. So cost and debt, these are all. So few more tools, those are widely, few more issues they are used. And in addition to that, the most important thing that I just want you to understand is issue. What does an issue mean? Okay, here is that you can see that issues, and these are all the issues. There are mainly three types of issues, and after that, that's a severity of an each issue. So what does an issue mean? So when a piece of code does not comply with a rule, an issue is logged on the snapshot. An issue can be logged on a source file or a unit test file. So there are three types of issues mainly. One is bug, code smell, and vulnerability. So we have discussed a bug, a code smell, but we haven't discussed about the vulnerability. But these are all called as issues. So here you can see that main three types of issues. That's a bug and vulnerability and code smell. Okay. So then we have a few more concepts to understand. We measure. How do you measure that? So the value of a metric for a given file or project at a given time. For example, 125 lines of code on class, my class, or density of duplicated lines of 30.5% on project. Of my project is called the measure. How do you measure that? So let's get into the rules and quality profiles and quality gates. Now you can see that this is the value. This is called the measurement. This is what we call as a metric. You see that? The metrics. These are all called the metrics. So how many metrics we are used? These are conditions, but the values are called because we are using the measurement. So that's what we call it as a metric. So or a measure. So this metric, a type of measurement, metrics can have varying values or measures over time. Examples, some of the examples that you can see on your screen, but I'll tell you few more. So number of lines of code, complexity. A metric may be either qualitative, means gives a quality indication on the component. Example, density of duplicated lines, line coverage by tests, etc. Or quantitative, it does not give a quality indication on the component. Example, number of lines of code or complexity, etc. So that's what the metric. Here you can see both. One is qualitative, a technical debt ratio is less than 5.4 debt, and others are quantitative. Example, bugs which are greater than 60. Okay. So that's a different metric. So either you can go for the qualitative metric or quantitative metric, but this is one type of measurement. Okay, and a few more concepts. That's a new code definition. What is the new code definition? And a change set or periods that you're keeping a close watch on for the introduction of new problems in the code. Ideally, this is since the previous version, but if you don't use a Maven-like versioning scheme, you may need to set a time period such as 21 days. So after that, whatever the code that enters, the code that you pushes is can be called as a new code. So then we will see quality profile, a set of rules. Each snapshot is based on a single quality profile. So a set of rules is known as a quality profile that we have discussed. Here you can see that a quality profile. And then rule, a coding standard, a rule is nothing but a coding standard or a practice which should be followed at any cost so that you can have a clean as you go code, a clean code. So not complying with coding rules leads to bugs, vulnerabilities, as security hotspots and code smells. So rules can check quality on code files or unit tests. It can be the rules, the whatever rules that we have in this quality profiles. Let me click on this rules. This set of rules is nothing but a quality profile. So in this rules, whatever rules that you mentioned that can be used to check for the source code and as well as the unit tests that you write to test your source code, that test your application. So for both, it can be used. I think you're getting my point. I'll elaborate it. See, for example, you have built an application. So it's obviously source code. So now, so this source code can also be tested. This source code can also be analyzed, okay, using these roles. In addition to that, you write a test cases as we have written for the API in our previous part of this seventh module. You write the test case script. Now you can check that test case, you can check that, you can and do analysis for the test case script also. That's what I'm saying. Okay, I hope you got it. So then we have remediation cost. The estimated remediation cost is nothing but remediation, the estimated time required to fix vulnerabilities and reliability issues. That's what the cost is. That so a snapshot, a set of measures or issues on a given project at a given time. A snapshot is generated for each analysis. It's nothing but a report in a simple words. And what else we have here is a security hotspot, a technical debt and vulnerability. So that's what we're gonna see. So a security hotspot, I'll show you. Come to the quality gates, sorry, issues, rules. Let me scroll down. Yeah. So we have seen the bug, and now we're gonna see into the security hotspot. Here is that. So security sensitive pieces of code that need to be manually reviewed upon a review. So you will either find that there is no threat or that there is vulnerable code that needs to be fixed. And let me click on security hotspot, and so that you can see some of the example of rules. So accessing Android external storage is security sensitive. Fantastic. And allowing both safe and unsafe HTTP methods is security sensitive. So that should not be done. And allowing browsers to perform DNS prefetching is security sensitive. So these are the rules related to the security hotspot. So you have to be very careful in dealing these things, or else you will be vulnerable for the attacks. So then what is vulnerability? I'm saying vulnerable for the attack. What does it mean? So vulnerability is nothing but a security related issue which represents a backdoor for attackers. Who is that attacker? A hacker. So that's what a vulnerability. Vulnerability is nothing but a security related issue. It is also an issue. Okay, but it's a security related issue. You can see that there are three types of issues: bug, vulnerability, and code smell. Okay, so a vulnerability is a security related issue. So what will happen because of this? Because of this, it creates or it represents a backdoor for attackers. So they'll enter into your premises, they will enter into your application premises, and they'll do whatever they want. It's like intrusion, intrusion into your application, invasion. They'll invade your app like Mughals did, Britishers did. So, and the one more thing that we have is technical debt. So the estimated time required to fix all these maintainability issues or code smells is called technical debt. That's it. So, and remediation cost, and then technical debt. So the estimated time required to fix all these issues are called as a technical debt, whereas the remediation cost is the estimated time to the estimated time to required to fix vulnerabilities and reliabilities issues are called remediation cost. So that's the difference between the remediation cost and technical debt. Okay, technical debt is only to fix all the maintainability issues such as code smells, whereas the measurement of estimating time to fix all the bugs and other vulnerability or security issues, we call it as a cost, a remediation cost, whereas if it is related to only maintainability, we call it as a technical debt.